Okay, so I'm John, and today I'm going to talk about Patchview, LLM-powered worldbuilding with generative dust and magnet visualization. And this work is done with Supremacy, and this is the first full paper work from our group, Midjourney Storytelling Lab. So today I'm going to talk about how we might be able to make use of AI in terms of helping creative writers do the storyboard building. So storyboard building is a process of constructing a coherent storyboard so that outcoming stories can have some kind of consistency within that and a compelling kind of dynamics within the story. So for instance, if you think about the SF word or advantage words, those kind of words are different from the word that you're living in. So the creative writers needs to create many of different elements that can be included in the word, such as different characters or places or props or so. And if you think about it, when we are constructing these kind of words, we need to create many different elements. So it can be quite actually effort-some, labor-some process. And due to that, it usually tends to be quite a collaborative effort between multiple creative writers. But here we're kind of thinking, what if we can make use of the generative AI, such as large language models, to help users storyboard building process. So we can large language models can generate different content by prompting these models. For instance, here this is the case of me asking, what if we are thinking of the word that is full of iced butters, and then what if we think about the kind of characters that can be included in this word. So as you can see in this case, the large language model can kind of generate some kind of plausible character description, and we can adopt them if we like them, and we can discard them if we don't like them. So there can be some of the opportunities regarding this large language model can potentially help with the word building process and potentially accelerate the process. So, however, here I'd like to mention some of the potential challenges regarding actually using AI models for the word building process. The first thing is that these AI models tend to generate these generate this text quite quickly, faster than our reading speed. So due to that, if you think about it, users might end up generating too many elements, and then they might not understand what they have generated before, and then that might very they might overload the user with a number of many elements. So yeah, so there can be definitely this kind of sense-making problem if user is continuously using this kind of technologies for generating the word element. So there can be that type of problem. And also, if you think about steering the generation towards what the user really wants, there can be also some kind of a steering problem. That is, when we're using this large language model, we tend to use natural language prompts as a default interaction. And sometimes natural language prompt is great, but sometimes there can be some limitations. Things like imagine there's a creative writer who wants to create 10 different characters who are subtly very different in terms of good and evilness. And if you want to make a new character who's slightly different from other characters, but still have some nuances, characteristic, expressing those kind of concepts or ideas in natural language prompts only can be quite a cumbersome or a difficult process. So there is definitely that kind of steering problem. If you generate many of the word elements that can be included in the storyboard. So Patchview is basically built and designed to tackle those type of problems, and we use the dust and magnet visualization, which is already existing type of the visualization, but we adapted it for the context of using the generative models. So here, many of you might not know what the dust and magnet visualization, so I'll try to explain what it is. So in the context of the storyboard building, if you think about the storyboard elements such as characters, there can be some kind of high-level concept that might be relevant to these storyboard elements. So for instance, for the characters, these characters might be associated with different factions, for instance. So here, those factions in this case can serve as a high-level concept, and the word elements will be more of the lower-level instantiation of each of the element. And here in the dust and magnet visualization, those high-level concepts serves as a magnet, which and then those low-level elements will serve as a dust iron particle. And then if we think about the magnet and iron particle, the iron particles are dragged to these magnets. And then here, the interesting thing about the dust and magnet visualization is that these intensity of the attraction would be based on the relevance of each of the word elements to the concept. So that is, if the word element is more relevant to a certain concept, then it will be dragged with more intensity. So it will be placed closer. So I'm going to give you an example because it was quite a basic description, I think. So let's say there's three different factions that the user is kind of considering. The one is the purse something, and the second is like mystical something, and the third one is the scratching clothes clan. And the user is kind of considering this character, serve, Poncelet, whisker, turn, third. And if you read this underlined part, this character is a spy master for the scratching clothes clan. So this character is definitely more relevant to scratching clothes clan compared to the other two factions. So within this dust and magnet visualization, this character will be placed closer to this scratching clothes clan compared to the other two factions. So this is basically way how these relationship between concept and the word element can be visualized in this visual concept space. And then with this kind of visualization, we kind of expected users to do better sense making of the word element generation as they generate element according to these concepts. So that's the thing. And here, one thing to note is that with this visualization, this kind of positioning of this element is done by a large language model with the recognition capability of the model. So this is kind of done automatically within our system. And moreover, because many different users of the creative writing might have different word structures, and they might be interested in different types of the concept, this tool also allows users to quite flexibly configure those different concept space. For instance, if the user is interested in how those characters, their characters are distributed in the according to different factions, they can try to configure that kind of magnet space. And also if they're interested in how characters are distributed differently according to good evilness, lawful chaoticness, or their magical aptitude or so, they can try to flexibly configure those magnet space. So they can either type those concepts in, or they can use an existing word element as a high-level concept to the high-level concept. So. And here, I would like to say that there's another benefit of using this a conceptual magnet space. That is, this magnet space can also serve as a means to steer the generation. That is, let's say a user is kind of wanting to create a new character, which is for instance associated a little bit more with the scratching clothes clan, which is at the bottom, or still has some relevance to the other two factions. And here, if the user wants to very subtly control that intense relevance to each of the faction, expressing that with the natural language prompts can be a little bit tricky. But with the Patchview, with this visual magnet space, that can be quite simple. They can just place the visual marker and then indicating that please generate the new character at this point. So those kind of subtle expressions can be easily done with this kind of visual input. And moreover, this kind of visual space can be also serve as a means to correct the AI's results. So there can because the visualization and the steer generation are done by this large language model, there definitely can be cases where these AI's results might not align with the user, how the user thinks it should be done. So in those cases, the user can also leverage this visual space itself to correct the AI's results. That is, if the tool place this specific word element in the wrong place from the user's perspective, they can simply drag it. Or if they think that this description of the word element is kind of misaligned with, or it needs to be revised, they can simply drag it while holding Shift key, and then the tool will try to rewrite this word element's description so that it can be placed in the user's newly indicated position. And here, there's one interesting opportunity regarding this user's correction. That is, with the user's correction added to the system, we can leverage those user's correction to better align AI's behaviors to the user's perspective. That is, I guess, more technically, we kind of use those user's corrections as examples to put into the large language model's pipeline, expecting that large language model's pipeline would get more closer to the user's expectation as these kind of user corrections are more accumulated. So, talking about a bit of technical details, we use the Cloud 2.0 for this these large language model features, and then we use the chain of the prompt engineering. And one interesting thing to note is that even with the prompt engineering, this kind of recognition of the concept in the continuous scale, and the steer generation on the continuous scale was kind of doable only with the prompt engineering. So it was kind of a surprising finding, but we could see that the capability of the instruction following has been improved to the level of being able to serve those kind of tasks. So it was kind of surprising, but at the same time we adopted those. And then I like to a very briefly mention of the user study. Like there are more details in the paper, so like refer to it if you're interested in. So we conducted a user study with 8 hobbyists and 1 expert, and we could see that these kind of visualization definitely helped the users with the sense making. They were more faster and accurate in capturing the information, and also they could configure this word element a space, words element space based on the concept of their interest. Like for instance, in this case, you can see the user kind of configure this space about the physical strengths and magical aptitude or the alignment. So we could definitely see that, and definitely users use this steering function to express more nuanced intention. But one of the limitations of the current system is that the leveraging users' correction for the better alignment of the AIS behavior, that feature has some of the limitations, interestingly. So more specifically, with the when we analyze the users' log data, with the addition of the more users' correction, the recognition error, which is visualization error, dropped a little bit, but it was the coefficient was quite small, so it was very minimal. And then regarding the steering, with the addition of the more examples, the errors didn't really got impacted by the addition of the more examples. So I think it indicates to the interesting future work that there might be a more technical improvement regarding this kind of interactive machine learning with the system when we're using a large language model. Simply putting them into the large language prompt didn't work in our case specifically. So there might be more of the work that needs to be done in that context. So this is basically all of the things that I want to talk about. So there are definitely more details in the paper. So if you're interested, please read the paper. But the high-level takeaway is that visual interaction can help users to sense make, steer, and correct AI generation. And I think this is only the one instantiation within the our context of our interest. So there might be more other types of visual interaction. So I think we can think about more of the interesting approaches in the community. So yeah, so this is basically it for today. And short note is we're definitely doing this type of storytelling research, and then we're looking for interns. So if you're interested in, reach out to me or Max who's here. So yeah. So yeah, thank you for listening. I'm happy to take any questions.
Hey John, great talk. Brian Wong from Adobe Research. So I think this tool is a fantastic tool for sense making, LLM output for world building. I want to ask about a question that's a step forward. Let's say I have a world build with this tool, and I'm a novelist or I'm a game designer. If I use this kind of foundation to build my world in the novel, for example, how would users feel about the ownership or the originality from this kind of generation? Do they really identify this kind of creation as their own creation? Would they struggle on that? Can you comment on that?
Yeah, definitely. We have some of the line of work looking into those kind of aspects, like how much of the user control we should give, during the process of this generation. So definitely, one of the things that we're kind of identifying from the multiple project is that with the more of the gradual process of this generation, users tends to have more of the sense of the ownership. It seems like. So for instance, we can so right now in this project also it is more of an end-to-end generation for each of the character. But if we want to facilitate the users a sense of the ownership, then we might want to actually divide this process into multiple steps, or as a more of a combination of the inputs, I think. So definitely, I think this work has some limitation on that sense. Users might not feel great a sense of the ownership, but definitely by allowing users more control handles, and by dividing this process into more steps, I think users would definitely tends to feel more sense of the ownership. Yeah.
Awesome. Thank you so much.
Thank you. Thank you.